Hey guys, this is a problem on races and tracks in time and distance. The question is this. In a race, A gave B a head start of 300 meters. If the ratio of their speeds is 5:2 and both finish the race at the same time, find the length of the race track. Let L be the length of the track. Let's draw the diagram for the problem given here. Let this be the starting line. A standing here. This is the length of the track and this is the finishing line. Here the problem says A gave B a head start of 300 meters, means B stands 300 meters ahead of A when the race starts. So B is starting here, A is starting here. And it's given that they've both finished the race at the same time, which means B is running a distance of L minus 300 meters, whereas A covers a distance of L meters during the same time. We don't know what time they took, but during whatever time A finished a length of L meters, B was able to finish a length of L minus 300 meters. That's the meaning of the question. So here is a problem with the time being constant, as you can see. During the same time, A finishes a certain length of the race and B finishes another length of the race. So when you have a time being constant, we know that distances covered by two moving bodies, if it is d1 and d2, the ratio of the distances covered will be the same as ratio of the speeds when time is constant. In this problem, the ratio of distances covered by A and B are L by L minus 300. And the ratio of the speeds is given to be 5:2, which means 5 by 2. Now just cross multiply and solve, you get what they want, which is the length of the racetrack. This implies L is equal to, take 3 to the left side, 500 meters is the length of the racetrack. There's a simple problem from races and tracks. We'll do one more problem to help you get a better understanding on the problems on racing. Here is the second problem from races and tracks. In a kilometer race, A beats B by 50 seconds and B beats C by 25 seconds. If A beats C by 300 meters, find the time taken by C to finish a race of 2000 meters. Here we know the length of the racetrack to begin with. They say A beats B by 50 seconds. Again, for the same race, B beats C by 25 seconds. Combining these two, we may conclude that A beats C by sum of these two, which is 75 seconds. This is 50, this is 25. The sum will be this. Now, distance wise also they say A beats C by 300 meters. So we know how A beats C by time wise, again A beats C by distance wise. What does this indicate? During whatever time A finished the race of 1000 meters, C was able to cover only 700 meters. Rather, C has to cover additionally 300 meters. And this shows, supposing A had taken, say, T seconds to finish the race, C will take T plus 75 seconds, which means C needs 75 seconds additionally to cover the additional distance of 300 meters. So combining these two, we can conclude that C needs 75 seconds additionally to cover 300 meters. Which means what? If C needs 75 seconds to cover 300 meters, that gives you the speed. C's speed will be 300 meters. It covers in 75 seconds. So 300 by 75, which is 4 meters per second will be the speed of C. So you got the speed of C. And what is the question about? Time taken by C to finish a race of 2000 meters. So the distance C has to cover is 2000 meters. We have found out C's speed, which is 4. So this is distance, this is speed. Distance by speed gives you the time. This on simplification, 500. So 500 seconds is the time taken by C to finish the race, 2000 meters. Let's do one more slightly more difficult problem before winding up today's session. The third problem is, in a race, P beats Q by 60 meters, Q beats R by 100 meters, and R beats S by 150 meters. If R is 33 and 1 by 3% slower than Q, then by how many meters did P beat S? Here we don't know the length of the track. Let L be the length of the track. Now the problem says P beats Q means 60 meters means when P covers L, Q will cover only L minus 60. Similarly, Q beats R. This implies L minus 100. Then R beats S means when R covers L, S is able to cover only 150 meters less. This is what the data say. Now let's look at the speed between R and Q. We can have a relationship between the speeds of R and Q. R is said to be 33 and 1 by 3% slower than Q. This implies what? 33 and 1 by 3% is nothing but 1/3, which means R is 1/3 slower than Q. That implies, okay, let's assume the speed of Q as 1 so that you can find out the speed of R. If Q's speed is 1, it's an assumption, then R's speed will be what? 1/3 less than 1, which means 1 minus 1 by 3, that is 2 by 3. Now we can write the ratio of their speeds. A ratio of speeds of Q and R is 1 is to 2 by 3. This implies 1 by 2 by 3. Rather, this will be 3 by 2, which means 3 is to 2. So basically, the meaning of R being 33 and 1 by 3% slower than Q means ratio of their speeds will be 3 is to 2. Now come to this portion. We will combine this and this. See, during whatever time Q covered a distance of L meters, R was able to cover only L minus 100 meters. And this is happening during the same time. So time is a constant in this case. Now, as we saw in the previous problem, if two moving bodies cover distances of d1 and d2, when the time is constant, the ratio of their distances will be the same as the ratio of the speeds. Here we are looking at the distances covered by Q and R. Q covers L during the same time R covers L minus 100. This is the ratio of the distances, which is equal to ratio of their speeds, which we found out to be 3 is to 2. So you have this. Cross multiply, we can easily find out L. 2L, 3L minus 300. This implies, take this to the, finally you will get so L is equal to 300 meters. Now the question is about by how many meters did P beat S? Okay, we can easily find out that once you substitute L equal to 300 meters here. So we got the length of the racetrack. Substitute 300 meters where we had started a solution with. Go back to the problem and take a close look at it. I can't show you that in the video. So for you to follow the discussion of the solution further, take a look at the problem again. Now we have written that P covers L, Q covers L minus 60. Put L equal to 300, you get this. Similarly, Q covers L, R covers L minus 100. Substituting L equal to 300, you get this. Similarly, R covers 300, L covers 300 minus 150. So 150. So this is what you get by substituting L equal to 300 meters in the solution we had started with. Now look at this. We can find out the relationship between P and R using this. Here P covers 300, Q covers 240. Whereas here Q has a value of 300. So try to bring 240 here. I mean, how much distance will R cover when Q covers 240, so that these two will be equal. To find it out, see, I'll write it again. Q and R, if you take, when Q covers 300, R covers 200, which means what? When Q covers 1, R will cover 200 by 300. If you know the distance R covers when Q covers 1, you can easily find out the distance R covers when Q covers 240. You just multiply this by 240. On simplification, you will get 160. So what do you see? Now comparison is possible because you got the same value for Q. This is how you combine multiple ratios into one ratio. We are using that principle only here. This I have covered already in my video covering basics of ratio, proportion and variation. You may go back to those videos. I'm giving a link of that video in the description below here for your reference. Similarly, let me write this again here, a little away from here. I don't have space here. So this means R covers 300, S covers 150. So that when R covers 1, S will cover 150 by 300. When R covers 160, S will cover that into 160. Why I am taking 160? Because R is 160 here. So I'm going through this chain and we are trying to link P to S. Now look at this. Let me write P and S here. Now P covers 300, Q covers 240, and when Q covers 240, R covers 160, and when R covers 160, S covers so much. This on simplification you get 80. So finally, if you go through this PQRS, you will arrive at this conclusion. When P covers 300 meters, S is able to cover only 80 meters, which shows what? P beats S by 300 minus 80, which is equal to 220 meters. So this is the final answer to the question. P beats S by 220 meters. I've done 3 problems on races and tracks in today's session. If there is any point you're unable to follow in my discussion of the solution, raise it in the comment section. I will address it there.